G4. Okay, and this one it doesn't pass. And then for the final one, you can apply this one. So C over R is equal to P1 time with delta 1 plus P2 times delta 2 divided with delta 1 minus L1 plus L2. Then you apply P1, you got it is G1, G2, G3, okay. Then plus with P2, G4, delta, oh, so this one need to time with delta 1, equal to 1 plus G2, G4 time with delta 2, 1 minus L1 is minus G2 H1 divided with 1 minus L1 minus G2 H1 minus G2 G3 H2. Okay, so P1 G1 G2 G3 and P2 is G4, delta 2 is 1 minus L1, which is 1 minus G2 H2, this one, and this one minus G2 H2 minus with G2 G3 H2. Okay, then this one you simplify it and then you can get the answer lah. Okay. Okay, so you can see at my note lah, right? Okay, any question for the signal flow graph? Ada apa-apa soalan tak? Any question?
No question.
No question.
No.
Okay. Who is that? Tennis, right? View all. Okay.
James.
Oh, James. James. James Kwan. All right. No. Okay. So we are done. For the signal flow graph, if you want to check whether you get the equation from the block diagram manipulation is correct or not, you can compare it with using the signal flow graph. Okay, so it's quite easy, right, compared to the block diagram manipulation. Okay, right? Can I delete? Boleh? Dah It's no control set.
Dah salin dah.
Oh, dah salin dah. Oh, senang salin just snap Right. Zaman digital zaman digital just snap. Okay, how about the budget? How much that you got it? Ada apa-apa bantuan budget? You dapat berapa?
RM50.
50
Betul,
ringgit.
nanti kena simplify kan ya?
Yeah, simplifykan as much as you can lah.
Kalau tinggal sini toleh ada tu
Tinggal tu boleh lah tapi tak dapat makan penuh lah kan.
Okay. Okay.
You try to simplify, right? Like this one, right? Maybe if you can do the block diagram manipulation for this one, right? This one I think is quite easy for the block diagram manipulation. The first one, right? First one, you can solve which one first? Yeah, look at the junction. Okay, this one and this one. Yep, this one is the closed loop. Okay, right? Closed loop. You solve this one, and then after that, the closed loop you solve with this one. You combine with G3. Done. And then after that, then you got it one block diagram here, and this one no junction as I mentioned. What you need to do? Okay, you can do this one. You transfer to this. Yep, you transfer to this. Okay, and then you can combine G1 after that. How to do that after that? And then again And then and then you solve this one, and then you bring the G function to the right, to the right, and then you can solve after that lah. You can solve maybe this one and the middle one H2. Alright? Okay. Boleh faham tak? Boleh Boleh? Solve this one and combine G3, and then this summation maybe need to move to the left, okay, so that you can solve G1 and also and this one. And then after that you can solve it so that you can get it the same result with this one. Okay, it will be the same result. Okay, all right. So we have finished the chapter 2. Okay, mechanical system and so on, and now we go into the chapter 3. A little bit about chapter 3 lah. Okay. Boleh? So far okay? Boleh Saya boleh proceed? Okay.
Boleh.
Alright. This is theoretical lah. Okay. In the chapter 2, we have learned on developing the mathematical model, right? So we already got the mathematical model. Then we want to know the performance. So why we want to know the performance? So that we can see the kind of the graph lah. Okay. So so we can see the time and so on, right, of the output, because we want to what we call it to know about the response of the output. Okay. So when you want to know about the response of the output, that means you also need to know the kind of the input. Okay. For example, this is our final block diagram lah, for example. So our output now is X node, right? And then this one is Xi, right? Then this one is our equation for the block diagram. So let's say your input when you put it in the step input, right? So there are a lot of input there, step input, right? For example, this one. Okay. So your output, it should behave like step input also. Okay. So maybe the step input will be like this one. Okay. This is the output, right? So this one over T, this one over T. So input Si also over T and S naught over T. Okay. So the output will be the same with the input, almost same. Remember, the control system, the purpose is to be sure that the output, we call it the desired output should be equal to the input, or we call it a reference. Okay. So whatever type of the input that you give it to this system, so the output should be same like the input. Okay. And step signal, all right, and the impulse signal is like bumper, right? When you are driving your car and then you have a bumper in the road, right? That boom. Okay, this is the impulse signal, sinusoidal signal and ramp signal. But for normally in this subject, we will play around with the step input because it's quite simple. Okay, then and in order to know the relationship between the output and input, so we can analyze the time response. Okay, so in this one we can draw the output, right? So we will get it this kind of graph. So we can divide it into a transient state, right? The first state that the output will be behavior, and then and then after that we will go to steady state, right? It's like when you set your air conditioning, right? You set it as for example 24 degree, right? So the output, right? When you measure the temperature at your room, so it will be like, yup, it will be okay, maybe what we call it, it try to overshoot, oh maybe 20 degree, right? And then it will knowing that, oh 20, 22, oh 23, and then oh okay, after that you got it 24, all right, for example. Okay, so this one we can divide it into two state, right? Transient and steady state. Okay, all right. The model that you have derived from the system, you can solve it, right, by using the Laplace transform. Okay, so Laplace transform can solve the differential equation. Okay, so look at this one. Um, from this one, you got the system, right? The mass and the spring and the damper, and then you come out with the free body diagram and spring equation and so on, and then you come out with this block diagram. Okay, so let's do from the free body diagram. Okay, let's do the Laplace transform. Okay, so what we can solve it, right? Okay, just the blue pen. Now, from that system, you got it Fs plus Ft equal to md squared x naught. Okay, so this is the small letter. Okay, I will explain to you. Okay, now you got it this equation for Fs and plus with C dxi equal to md squared x naught. Okay. Then after that, ksi ks naught. Okay. Laplace transform is more on mathematical solution. Okay. And then you can combine with k plus cd. Now you bring this one and d squared plus k. What did I miss? CD. Yep, this one I miss it. K plus kx naught. Now you got it kcd xi and md. Okay, sorry, plus k. No, all right. Okay. So now you can find it is x naught equal to k plus cd, and then md squared plus cd plus k xi. Okay, so all d, this one, that's mean d over dt, right? All is over time. So how to solve this one, time one, right? That means you can use the Laplace transform, right? You can use the Laplace transform, and then you will get back the t, right? You will get back the we call it, this one is Laplace transform. That means Laplace domain, and then you can got it a time domain or time response. And in order you to draw the graph. Okay, so this is the concept lah. Okay, so before that, let's learn what is the Laplace transform. Okay. So I hope that you already know about the Laplace transform. So when you got the function for example, ft, right? ft, so you can Laplace it. This one, the symbol Laplace, ft. So it will become the capital. This one, the small letter f, and then it will become capital F, and then the domain is S, Laplace S, right? Okay. It is equal to integral 0 to sigma infinity, 0 to infinity. Now we only choose 0 to infinity. Okay, and then you need to time you call it est, and then you time with your function ft over dt. Okay, so this is the concept, right? In order to when you Laplace the time domain, you will got it in the Laplace domain, but in mathematically you need to time with exponent minus st, you time with the function, right? And then you integral. Okay, right? So like for example, you got it yt. Okay, so when you Laplace yt, you will got it capital S. Yt, you got a capital S. Sorry, capital Y, and domain is S. Okay, and then when you Laplace it, what we call it, the small letter x I t. Okay, all right, and then plus with x naught t, for example. Okay, when you Laplace it, so here we got it is xis plus with s naught s. Okay, something like that. Okay, right. This one I think is clear, right? Okay, so let's look example 2.2. Okay, let's remind back what you have learned in Laplace, maybe in your matriculation or secondary school. Okay, so you got it is function ft equal to 1. So what is mean? It mean if we plot the graph t, so this one is ft, alright. So it will normally go to ground, so from 0, okay, and then the last one is 1, right? And then it will constant 1. So that's why we got it ft equal to 1. Okay, all right. So let's derive this one. When you Laplace ft, that means is equal to fs, right? Fs, and then equal to 0 infinity est, you time with 1, right? dt. Okay, so we try to solve it. 0 infinity est dt. Okay, boleh Is it okay? Is it okay? Ada apa-apa soalan? Tak ada Clear Hello? Is it okay?
Boleh.
Boleh
Okey, okey, boleh.
Okay, boleh ikut
Boleh ikut.
So you can say L1 and L2 for delta 1 because they are in between. Oh, dah lepas lah nanti TM saya. Okay, so how to solve this one? I think you already know about it. So this one we just replace it u minus equal to st, right? Okay, then this one you will got it 0 infinity eu. Okay, so to solve the u st, so we got it is du over dt is equal to minus s, or dt is equal to minus 1 over s du. Okay, alright, done. So now we put it eu, yep, dt is equal to minus 1 over s du. So this one is 1 over s, 0 infinity eu du. Okay, and we can when we integrate the exponent, right, over du itself, so we can get it is e u and then 0 to infinity. Okay, and then we put it back. What is u? Eu, that's mean e minus st 0 infinity. Then we can solve it minus 1 over s. E minus infinity minus e equals 0. Okay, and then e power of minus infinity, that's mean you will got it 0, and e of power 0 you got it 1. Then the final one is you will got it 1 over s. Now when you Laplace ft is that equal to 1, you will got it is 1 over s here. Okay, right? So this one, the solution that from the time domain, how to convert to Laplace. So you need to multiply with e power of minus st. Okay, done, and you paste this one. Okay. Alright, no question, right? This one, tak ada apa-apa soalan kan? Okay, so the next example, okay, how to solve the e power of minus t. So this is already in the your notes, right? And then you multiply with e power now st, you solve it and so on. That you can see that for the Laplace for ft that equal to e power of minus at, you will got it this kind, right? Question 1 over s plus a. Okay. So however, you will be given the table, right? Okay, the table. Okay. Right. So like the pass input where the t equal to 0, the unit step, all right? This one, the unit step input, we got it 1 over s. We got it for the ramp input. So when we Laplace, we can got it 1 over s squared, s power of 2, and then for the polynomial, right, you need to factorize. So the one important thing is this one, EAT is 1 over s plus a, right? If you got it plus, so it will be minus, sign and so on. Okay, the rest is about when you Laplace, d, all right, is equal to when you Laplace d over dt. Okay, so this one will be equal to s, all right, fs minus with the f0. Okay, right, we will see into that. So when you Laplace d squared is equal to s squared fs minus with s f no minus with f0. So what is mean this one? Okay, this one and so on. Okay, I will explain to you. And when you Laplace third derivative, it will be like this one. Okay. All right. So let's look at this example. Okay. So the example, you got it K1 spring and also damper, where is the K equal to 1 and C equal to 1. When you do the free body diagram, you will got it this kind of equation where your mass, we can say that this point have the mass equal to 0, okay, in order to draw free body diagram. So now you got it this kind of equation, F equal to Ft. Okay, so let me show it to you. So you got it is Fs equal to Ft. Okay, because you have got the spring, right? So it's like, okay, so this one you can make it as the mass, right, equal to 0. Okay. Fs plus sd, now you got it, is xi minus x naught. This one fd, you got it, is cd x naught, because the only one is free and one is rigid. Okay. Now try to bring this one at the left, right? Kxi minus kx naught equal to c dx naught. Kxi equal to c dx naught plus kx naught. Okay. So now you got it cd plus k x naught equal to kxi. Okay. So it gives you c and d equal to 1. So you got it only d plus 1 here. Equal to x naught equal to kxi. Okay. Make it is dx naught plus x naught equal to kxi. So all is in the same is the time domain, right? It's over t, and so on, right? Okay. So now when you do the Laplace, right? You Laplace dx naught plus you Laplace x naught here, and then you Laplace with kxi here. Okay. So when you do the Laplace, that's mean, okay, all right. So last part this one first. Like me, I'm like doing like this one. Saya suka buat macam ni dulu. Okay. So when you lepas dx naught, so you need to look at the table. So when you lepas derivative, it will equal to sfs minus f naught. So in this case, it will become as a small letter s naught. It will become the capital letter. Now you can put Laplace s, right? Okay, and then minus with x naught. This one, the f will be small letter x naught, and then 0. Okay, done. And then you Laplace x naught here. Of course, you will got it capital letter x naught s. Then you Laplace this one. Kxi, here we got it. Oh, k already equal to 1. Okay. All right. Then you got it is SIS. Okay. Do separately 1, 2, and 3. Okay. Then oh yeah, it given to you the x naught equal to 0. Alright, x naught, that's mean at the initial stage there is no displacement there. So what you can do is this one you can put it 0. Okay. So you only left this one and so on. Okay. Alright. And then you can solve it. You can combine it together for this equation. We got it as x naught s plus with x naught s. Okay. And then is equal to this one is xis. Okay. Please tell me if I'm wrong about it. Okay. Right. Okay. Good. Then you got it is s naught s plus 1 equal to SSS. Okay. Now, in this question, it tell you that xi is the input for a step unit inputs. That means the input, right? You give it to this term is kind of unit step input. So when the unit step input, right? This one, the unit step input, when you Laplace it, right? So let's see again at the table. Unit step input here, when you Laplace it, it will become 1 over s. So now the input will become 1 over s. This one we maintain s plus 1. And then the output you will got it is 1 over s plus 1. Okay. We want to find the final equation only for the output. Okay. This one is only for the Laplace. Okay. For the Laplace domain, we want to find only the output. Okay. When you apply the input, whether you need the input, then you can get the final one. Ada apa-apa soalan? Any question? Any question? Ada apa-apa soalan? Is it clear? Okay. Clear? Okay. Okay. So the final one you got it is x naught in Laplace domain 1 over s plus 1. For this one, you can make it 1 over s plus with minus 1 s plus 1. Okay. Okay. How to get this? We have a method, right? How to get this one. Okay. Alright. Okay. Just accept all this one first, right? So this one is not s. Okay. This is Laplace. How to get the time domain, right? This Laplace, how to get back the time domain? You need to do the inverse Laplace, right? Okay. So when you do the inverse Laplace, so look at the 1 over s. Look at the table again. 1 over s, right? From the Laplace to be time domain, 1 over s is equal to 1. Okay, so that means is 1, all right, minus 1 over s plus 1. 1 over s plus 1, right? S plus a lah, right? S plus 1 equal to e exponent minus t lah. Okay, actually 1 times t. Okay, where is your a now is 1, so is minus t. Okay, so you already got it in time domain. Okay, now you can plot this graph. Okay, it is like 1 minus 1 over e t. So how to plot the graph? Okay, this is t, this is x naught. Okay, so let's say is t equal to 0. Now you got it, it is not 0, 1 minus 1 is 0. So it start from 0, 1. Okay, so 0. So the first point it will start from 0. Okay, and let's say is t equal to infinity. Now you got it as not infinity, 1 minus e infinity. Okay, so this one, the biggest one, 1. So 1 minus 0, you got it 1. And the t, the infinity, the last one that you will got it is 1. That means your graph will be like this one. Okay, and then it will go to, okay. Alright, then your input before this is the step input. Okay, the input xi t is the step input. Okay, so it's equal to 1. This is your input, and the output you got it the same graph is like the input, right? But it have some delay. This one we will learn. So what mean this delay, right? It should be sharp like this one, right? It should be sharp like this one. Okay. Any question? Ada apa-apa soalan tak tentang this one? Any question? No? Okay. No question? No. Okay. So, in the real application, right? In the real application, for example, let's say the air conditioning, we put it is 24 degree. Okay, 24 degree. So, this the final one, you should get a 24 degree. Okay. But how many time that you will got it is 24 degree, right? This one, how many time, right? How many second, how many minutes you will got it 24 degree? This is the on the real life lah. Okay, when you apply 24, you set it, you set your controller 24, right? And then the system will do this to try to get the 24 degree, right? But how many time that you will got, right? Okay. Okay, so that's it. I think that's it, right? Okay. Same like this one. Given okay. Now we can use the solve equation. Okay. I think yeah, we can go with this one lah. Example 2.5, the final one. Okay. Sikit lagi. Right. Example 2.5. Everybody okay? Okay. You want to take a break?
Okay, sir. Okay, sir.
Okay, yeah. Okay. Alright. So, for this equation, when we solve it, we do the free body diagram here. So we got it like this one, MD, and then side, blah blah blah, and then you apply the C over M. It give it to you 3K over M. 2. You solve it, then you got it this kind of equation. So D squared x naught plus 3dx naught. You see, the time domain, it will be the small letter 2x naught equal to 3dxi plus with 2xi. Okay, now when you Laplace it, when you Laplace all these things, yep, okay, or you Laplace it, so you can make it like this one. When you Laplace dx naught, okay, so you will got it, do it one by one. So sy x naught s minus s x naught s minus or plus. So look at again the table minus, okay, and then minus with x naught. So this one will be small letter, and this one will be 0. Okay, and this one it have the okay. Alright, and then you apply this one s naught is equal to 0, and s naught this one is equal to 0. Okay, so this one, the initial state, right, at the time equal to 0, so there is no displacement, and of course this one is d over dt s naught, of course you don't have 0. So now we only left for squared x naught s for only this one. Okay, and then when you Laplace 3dx naught, so you got it 3 d, so s x naught s minus with this one, yeah, I'm also not remember. the formula. You got it at x naught here. Okay, so this one will be cancelled to 0. Then you got it with 3 as x naught. Okay, alright, I'm right. Okay, betul tak? Betul, okay. And then you Laplace again for 2 x naught s. So this one you got a 2 x naught s. And then you Laplace this one, Laplace 3 dxi. So you got it with 3 s xi minus with xi naught. Okay. So xi naught is not given to you, but we can say that because of this x naught you got it 0, so input also you can get it 0. So now you got it 3 s here. Okay, and then you Laplace again the 2xi equal to 2 sis. Okay, done. You are done one by one. Okay, and then you apply this to this equation. So you got it x2 s plus with 3s s naught s plus with 2x s is equal to 3s xis plus with 2xis. Okay, now we make it as okay, done. ds plus 2. Now xs, it said that yeah, unit step input, then you need to multiply with 1 over s. Now finally you got it is 3s2 s squared plus 3s plus 2. Okay, all right, so this is the final one that you got it. Yeah, same. Okay, so first you try to Laplace one by one, this one, this one, this one, this one, this one. You Laplace it, and then you apply what is the parameter given from the equation. Then you got it this one, you Laplace, apply in this one. And then after all you got it, you combine back to the equation. When you combine it, right? Then try to bring the output at the left. Okay, try to bring the output at the left and then the input at the right. So and then you apply the input, right? You apply the input. So normally it give it to you the step input. Then you got this kind of question equation. So now we want to make it this one as the fractal equation, right? Partial equation. This one for s, this one what is it? Okay, what is it? So how to solve it? This one, how to using the partial fraction, or we can say that the Riemann theorem. So you we do like this one. So this one we will learn this by on this Thursday. Okay, alright. So first of all, I hope that you already know how to apply the Laplace. Okay, boleh? Ada apa-apa soalan? So the rest we will continue on the Thursday. Okay. There is no question. No question right now. No.
No.
Okay. Alright. Okay. So I think that's it for today. I will see you again on this Thursday. Bye bye.
Okay, sir. Thank you, sir.
Okay, welcome.
Thank you,
Yes, sir.
doctor.
Thank you, sir.
Thank you.
Thank you.
Okay.
Thank you, doctor.
Thank you, Doctor.